find the radius and interval of convergence for this power series. Okay, so we have x to the n, which is same as x minus 0 quantity raised to n. Alignment center is 0. So in this case, center is 0, and we know for sure the power series always converges for x equals its center, x equals 0. This power series converges for x equals 0, but we want to check for more x values, and we always name this general term as an. Okay, and for x not equal to 0, because we already know for x equals 0, which is center, it converges. For x not equal to 0, let's find the limit of the ratio of an plus 1 over an when n goes to infinity. Okay, that is same as limit of an plus 1. So this is an plus 1. The next term would be n plus 1. Replace n by n plus 1. So negative 1 raised to n plus 1 x raised to n plus 1 over n cubed, which is n plus 1 cubed. Okay, that's an plus 1 divided by an itself. Negative 1 to the n xn over n cubed. Let's evaluate this limit. When we take absolute value, this becomes positive 1 all the time. This always positive 1, so we can disregard, and we have xn plus 1, which is same as xn times x raised to 1 and n plus 1 cubed. Let me change this division into multiplication. Then we need to flip this fraction, n cubed on the top over xn. Okay, this negative 1 to the n becomes 1, positive 1 all the time. Then xn cancel, and this limit is same as n cubed over n plus 1 cubed. These are positive numbers, and absolute x. This absolute x is independent of this limit, so we can pull all the way outside absolute x. Now limit of n cubed over n plus 1 cubed, and we don't need to write absolute value anymore. N cubed over n plus 1 cubed. Okay, and when we take this limit, this is the infinite limit, so depends on the leading terms. N cubed is the leading term. On the bottom, when we multiply n plus 1 3 times, n plus 1 by itself, again itself, the leading term would be n cubed. So n cubed 1. So this is basically the limit is absolute x. And we know by the ratio test, if this limit is less than 1, the power series, the series converges, and when this is bigger than 1, the series diverges. Then by the ratio test, the given series converges when for this limit of the ratio less than 1, and we don't need this part, but let me write diverges for x bigger than 1. That means this 1 is the radius of the convergence. So basically we have this situation, real number line, center 0, so radius 1, so up to 1 and up to negative 1. Okay, thus the radius of convergence r equals 1. Now we need to find the interval of convergence. That could be negative 1 to 1, inclusive negative 1, or not inclusive. So we need to test the series what happens when x equals negative 1 and when x equals 1. For now we are sure excluding negative 1 and 1, like negative 1 to 1, yeah, we know for sure the series converges on this interval. but we're going to test the endpoints as well, and we might be able to include one or both. Okay, so when x equals, let's say, left endpoint -1, the power series, the given power series, the question becomes, let's go up and see, when x equals -1, so -1 to the n times -1 to the n over n cubed. So -1 to the n, x and x is -1 to the n over n cubed, n from 1 through infinity. We can multiply these two because they have the same exponent, so negative negative positive 1 to the n, which is just 1. So this series is in fact 1 over n cubed, n from 1 through infinity. Okay, 1 over np. So this is a p series. This series is p series with p equals 3, bigger than 1. So this converges, which converges being a p series with p equals 3 bigger than 1. So we can include -1 in the interval of convergence. So we need to test. I mean, this is good. So this is now bracket. Now test for the right endpoint x equals 1. Okay, next, when x equals 1, the given series, the given power series, the original question becomes n from 1 through infinity, -1 to the n. We had xn, go up and see xn. Now x is 1 to the n, which is just 1 over n cubed, and this is -1 to the n, 1 over n cubed. Due to this factor, -1 to the n, an alternating series. Okay, this is clearly an alternating series. To test for the convergence, we use the alternating series test, where we only are concerned with 1 over n cubed. We want to show two things. Okay, for convergence, 1 over n cubed should be decreasing, and they should decrease to 0. So let's see, 1 over n cubed, when n is bigger and bigger, the bottom is bigger and bigger. So 1 over bigger and bigger is smaller. That means this 1 over n cube is decreasing. And when n goes to infinity, 1 over infinity is 0. So they decrease to 0 as well. Okay, an alternating series. Then by the alternating series test, okay, alternating series test, this series converges. That means 1 can be also included in this interval. Thus, the interval of convergence, interval of convergence, -1 to all the way 1.